In my video describing the coefficients of compounds in a chemical reaction, I want to make another video here to follow up and point out any misconceptions that I might have created from that last video. So in that video, I talked about what a coefficient is. And so it's these numbers in front of the molecules in a balanced chemical equation. And I described them as they represent the number of each molecule. So they could represent the number of each molecule individually. So each one of these numbers represents however many that number shows of that molecule. So we have 1 N2 here, or we have 3 H2 molecules here, or 2 NH3 molecules here. So it could represent numbers like that. Or it could describe a different descriptor of a number. So as I showed down here, it could represent the number of dozens of molecules. So a 1 here represents 12 molecules, or more commonly we could represent it as a mole. So a 1 here represents 1 mole of N2, or which 1 mole means 6.02 times 10 to the 23rd particles. But it represents any unit of just a number, or I don't even want to use the word units because it's definitely not a unit of measurement. It represents the number of that molecule in whatever descriptor of a number you want to use, whether it be just an individual number or a number which means 12 of it, or like a dozen, or a number which means 6.02 times 10 to the 23rd of it, which would be a mole. So whatever descriptor of a number you want to think of it as, that is totally correct. But what I made this video to describe is that I don't want us to think it means any unit of measurement, because what these coefficients do not represent is they do not represent a unit of measurement. So mass would be an example of something that these coefficients definitely do not represent. So these coefficients do not represent any unit of measurement. Such as mass, they do not represent mass. So if I tell you that I have a certain number of grams of N2, and I have a certain number of grams of H2, I could not just plug in the numbers into here. I would have to convert them into a unit of measurement that the coefficients do represent, like moles. So I'd have to convert from grams to moles before I can plug them into this equation, because otherwise it's not going to work. You're going to get inaccurate results. And the reason why that is because a molecule of N2 weighs completely different, has a completely different mass from a molecule of H2. So it's not something that you can compare through mass. Something else, though less common, would be like it definitely doesn't represent the volume. So if you have all gases, these might be gases. These are not going to represent the same volume because the molecules might take up different amounts of space. So volume would be another thing that it doesn't represent. So make sure that whenever we're thinking about these coefficients, we're thinking about them as really the number of molecules of something, whether that number be in the individual molecules, number of pairs of molecules, number of dozens of molecules, number of moles of molecules, where each mole represents 6.02 times 10 to the 23rd of molecules. But those are correct interpretations of what the coefficients represent. Things like grams are definitely not, so do not get that confused.